What if we already have the graph of a quadratic equation and we want to write the equation in vertex form? Because of the ease of identifying the vertex and the very significant role that it plays in writing the vertex form, if you know where the vertex is, it is oftentimes only one step beyond that in order to create the graph, the equation that matches a particular graph. So here for this example, we know that our vertex is at the point 2, 14, which means in order to create this parabola, we needed to move the parent function 2 units to the right and 14 units up. If we think of our generic vertex form as having 3 spots that need to be filled in, we already know 2 of the spots. We went right 2 and up 14. We also know that as we go through the rest of these steps, that A better end up being negative. We're going to need this parabola to open downward. The parabola can't open upward if A is positive, or if A is negative, but we're going to need it to be negative in order for the parabola to open downward. The key to determining what A is lies in one of the other points. If I know that a XY relationship between 2 points is when X is 0, Y is 2, I can substitute those values into the equation and create an equation that's only in A. So what that would look like is I take the Y out and I put the 2 in its place. I take the X out, I put the 0 in its place, and I'm left with an equation that's only in A. A is the only variable remaining. I could have used either of these 2 points or any other point that I could identify. I could use any one I want. I tend to use the y-intercept if it's at a nice location because it oftentimes will lead to a really easy simplification in here. But you could use the x-intercept if you're more comfortable with that, or if that's a nice point and the y-intercept isn't. That's oftentimes where you can be a little bit creative. But I'm going to use the y-intercept because that point was easiest to identify. I know that -2 times itself is +4. I'm going to subtract 14 from both sides. And then I'm going to divide by 4, and I get that A is -3. I knew my A needed to be negative. Check. It's negative. I knew that it needed to be, I probably could have saw from the beginning that it needed to be a number greater than 1 or have an absolute value greater than 1 because this thing looks a lot steeper than it should and than a normal parabola. The rate of growth is more significant in this one than we typically see in a parabola. So I had a suspicion that it was going to be a number that had an absolute value greater than 1. I don't know that until I'm done though. But I can rest assured that if I was to use either of those 2 points in X and Y, that I would end up with a similar solution. The downfall to using points that are decimals is you don't know if it's actually that decimal or if that is a rounded number based on the limitations of your technology that you're using or wherever the picture came from or your own estimation. If you have a perfect point with integer coordinates like 0, 2, that's the best option. If your x-intercepts had integer coordinates, then they would be the best option. But it's a matter of setting up what you know from the vertex and then using some other point to knock out the x and y, leave yourself with just something that's in the A, and work only with that.